So now we're going to take a look at another tool that's useful for stem setup called the stem alignment tool. So we already covered some kind of stem setup in the diffraction module, but now we're going to kind of move on to more EELS sort of centric setup, which is a little bit different to what we did in 4D stem, but there's some overlap. So the first thing I want to cover is the stem alignment tool. So the stem alignment tool is in the stem technique and the stem SI technique. So I'm back in the stem SI technique, and we're looking at the same sample as for the diffraction module. So we're looking at the semiconductor device again, and the setup is pretty much the same. So I've taken the small aperture out that we were using diffraction, and I've put the very large aperture back in. So let's get going. So if I press start, you see we get a camera image. So I'm in F10 mode using the GIF camera. So the stem alignment tool will always disable any kind of spot position that we have. So right now the beam is going straight down the center of this field of view that I'm looking at. So we're in vacuum. If we want to kind of use the stem alignment tool to do anything with the ronchigram, we need to be in the sample. So I'm just going to move over here. And yeah, so we want to put the ronchigram center in this crosshair. So by default, this crosshair is going to be in the center of the camera image. So actually, let's just take a little step back. I'm going to retract the stem detector, which is that guy there. And if I right click, right click and insert the high SNR aperture, actually what we want is, we want this to make sure that this red crosshair should essentially be in the center of this circle, because we want to be in the center of the GIF aperture. It's actually not, if we look at that. So if I click center over in the stem alignment tool, and then it allows me to recenter. So I can actually then move to kind of account for that small error, put that guy right there in the center. So I'm looking at this blue circle, making sure that's in the center of that kind of shadow, which is the GIF entrance aperture. Hits enter, and we're done. So now I want to use the PLA, so the diffraction shift on the microscope, to put the ronchigram at that crosshair position, which makes it really easy. Once we've done that, so that allows me to know where the ronchigram center is. We could go and do things like check the condenser stigmation or coma and things. It looks good, and Paolo's going to cover that in one of the next lessons. So I'm going to skip over that. We're just going to focus on this tool. So I want to insert the aperture that I want to use for probe formation, which is this 40 micron condenser aperture. And now what I need to do is I use the controls on the microscope to center this guy on that cross. So now we know that our aperture is well centered on the ronchigram, which is good. Okay, what else can we do with this tool? So if we were to change camera length or something and our diffraction shift changed, we can fix that with the tool automatically. So I'm not going to change camera length, but I'm going to just misalign my PLA, my diffraction shift. So we can control diffraction shift from within the stem alignment tool. So we can go shift in Y, shift in X, or I can just use this auto center. So that really should be done in vacuum. But usually if you have a bright diffraction disk, it's okay to use through the sample. Okay, so now what becomes like even more useful. I'm going to go back to my imaging aperture, get rid of that blue circle. So we can use this tool also to measure our angles, so our convergence angle, our collection angle. So if I click on this alpha button here, calibrate convergence angle, we basically just then, our red circle here is our kind of convergence angle. So it's just, we mark out the diffraction disk. So you can see that it was already correct, but if I put that there, then we can see in the tool that now my alpha, my convergence semi-angle is 7.28 milliradians for this aperture, this camera length. Now you can see that the big blue circle went away. So the blue circle just shows you the collection angle. So it's showing us the GIF entrance aperture. So we could have the high res aperture, which is that size, or I'm going to stick with the bigger aperture. So the high SNR aperture, the 5mm, is over there. Okay, so we can do exactly the same thing here. We can define beta. So we've got two options here. Okay, so I can't really see the edge of that aperture. An easy way to deal with that is just to just misalign PLA. So if I go over here, you can see where the edge of the aperture is pretty easily. So I then just press OK here and just increase the size of that blue circle a bit so it lines up with the GIF entrance aperture, and then hit enter. So now we've just really easily measured our convergence and collection angles just by drawing some circles on the image. Yes, and then let's go back to this projector alignment tool and then recenter, and we're good. Okay, so once we've done that, we can go to EELS mode. There's one more thing that I wanted to show you that's really, really useful with this tool. So I'm going to stop the camera view, go to EELS, and in just a minute, we'll be in EELS. Okay, so in the EELS palette, you see that there's this button here that says kind of beta star. So it's telling us what the effective collection angle is there in that button. But we can actually click here. It's not just information. So if we click on that button, it brings up the experimental conditions dialog. Now, what's really useful here is I already kind of set this, but you've got different options for how the experimental conditions are going to be populated in our EELS data that we acquire. So we can have user. That means that it's just going to import some number that we have to type in ourselves. Estimated, it's going to be a geometric estimation based on the detector position and the camera length. If we're on measured, now it will import the measurements that we just made using the stem alignment tool. And I'm fairly confident, we made those measurements ourselves. I'm confident in the measurements. So that's kind of what I want to use. So if you use the stem alignment tool to measure your convergence and collection angles, also remember to set that to measured in your experimental conditions. So we've got alpha, we've got beta, hit OK. I'm just going to grab an EELS spectrum and a little overexposed, but then go in here, right click, image info, session, EELS, and you see in the spectrometer info, we have our measured convergence angle and our measured collection angle. So until we change or kind of make any changes to our stem alignment tool, any spectral data, EELS data, or stem EELS SI data is going to have those measured angles in the metadata, which is really useful for analysis and quantification and everything further down the line. So it's a good tool to use. I recommend it. So that's everything to do with pretty much the stem alignment tools.